Morning.
My name is Asia, and I'm going to present a little scenario before I start my presentation. Tom, can you please stand here? Now, if you should look at Tom, he's a well-built, good-looking young man. But when Tom first came to my class, Tom was looking like this.
Whoa.
And Tom's aim was to look like this. So after the students teased Tom, he decided that he's going to eat and eat and eat for an entire year. So I went off on a year's leave, and when I came back, Tom looked like this. That was Tom. Right? So I spoke to Tom, and Tom said, "You know what, miss, I'm going to go to the gym." At the end of another year, Tom looked like this. The top big and the bottom small, with arms and all that. Tom decided now that he's going to take it in stages because he wanted the bottom to stay as it is, top and the arm and stuff to go down. So Tom decided that he's going to work with this part first. So that went down and his arms were big. So I asked Tom, what are you going to do to get your arms down? Tom said he's going to toss a coin. For how long, I don't know. So Tom, you can start tossing the coin to get your arms down. No, don't stop. Now, meanwhile Tom is tossing the coin, I want you to figure out the solution to this problem. Anybody? Imagine Tom still tossing the coin. Anybody with an answer?
What's the function?
P to the N. Probability of P.
The probability of
P of n?
P of N.
as n approaches infinity?
As N approaches infinity.
So the function is infinity?
Okay, one answer there, we have
No,
infinity.
I'm asking.
Any other answer? What about you? Okay. We don't know. So far, we have one answer. Now, the original problem is if Tom keeps tossing the coin as long as it takes. Let's say Tom dies at 300 years and until then he'll be tossing, he decides to toss the coin. How likely is it that Tom never tosses a head? How likely is it that Tom never tosses a head? Now, my topic is probability, but I'm going to show you how calculus, and my topic in calculus that I'm about to use is limits. How limits can be used to solve a problem like this. Now, the first step is to change the problem, the wording problem here, in a limit form. So my limit form is n, let n be the number of times Tom decides to toss the coin, right? So we already know that Tom will keep tossing and tossing the coin. So if he will keep tossing the coin forever and ever, the notation there to be used is infinity. Thank you. So you keep tossing the coin. So as n approaches infinity. So now, on the probability of the number of times that he tosses the coin will be Pn. So the problem is limit as n approaches infinity. I am saying our answer is 0. The answer we had was infinity, but I'm saying that it is 0 because this is my reason. Now if you toss in the coin, how many sides does the coin have?
2.
2 sides. Go. The coin has 2 sides. So when you keep tossing, the first time you toss the coin, let's say you had a tail. What's the problem? What was the probability that you had a tail? You tossed it 1 time, so the probability is half. Let's say you toss it 3 times. You toss it another time. Right? Now, as the limit tends to infinity, the probability becomes P is equal to a half, P probably equal to a quarter, P probably equal to 1/8, P equal to 1/16, and so on. Now, if this bottom number gets bigger and bigger and bigger, what are we tending to? 0. So that's why the limit as n tends to infinity is equal to 0, because P, when you toss the coin, as the denominator gets larger and larger and larger, it tends to get to 0.